Well, good day, ladies and gentlemen. I hope you're each doing well. This is the second of our 2 required sections for Hawks this week, properties and applications of logarithms. Before we look at these problems, let me go over some stuff that we have done before, looked at before, and some new properties about logarithms that will help us to deal with these problems. First, this is the 3 concepts that we examined in our last week's lesson on logarithms. The log base anything of 1 is going to be 0 simply because a to the 0 power will always be 1. Anything to the 0 power will always be 1. Secondly, log base a of a, log base anything of itself is going to be 1. Why? Because any value to the first power is going to be that value itself. This should read a, the first is a. Thirdly, log base a of a to the x, notice the base and the base. Log base a of a to the x is always x. Why? Well, it's redundant because a to the x is, of course, a to the x. This will all be in your notes. I'll put on quickly content. Once I finish this video lesson, I will post this as well. This is what we've covered before. This is what we've looked at before, these 3 concepts. We'll use some of this in the working of our problems. But in this section, we got some new stuff. Some basic properties of logarithms. Remember, a logarithm is an exponent. A logarithm is an exponent, so these things shouldn't surprise us entirely. It says, first of all, this. Log base a of a product, 2 things multiplied, is simply the log of the first plus the log of the second. The way you can say this in words is the log of a product equal the sum of the individual logs. For example, the natural log of 7 times z, hey, this is a product, equals the natural log of 7 plus the natural log of z. Now we're going to be using these concepts to what we call expand a logarithmic expression. Log of a product equal the sum of the logs. That's the first one. Here's the second one. Log of a quotient equals the difference of the logs. So the log of a quotient equals the log of the numerator minus the log of the denominator. For instance, this is log base 10, of course, log of 45 over x, hey, there's a quotient, equals the log of the numerator minus the log of the denominator. Now we're going to be going in both directions with these guys. We're going to be expanding them like this. We're also going to be condensing them, like going from here to here. So keep these concepts handy. Here's the third property of logarithms. Log base a of x to the r, notice the exponent, something to a power, equals r times log base a of x. So in other words, the exponent simply becomes a coefficient when I re-express or expand this exponential expression. The log of something to a power, the log of something to a power, equals the power times the log of that thing. So check this out. Log base 5 of x to the 6th, hey, there's an exponent. That becomes my coefficient, equals 6 times log base 5 of x. So we're going to be using all these properties as we expand and as we contract certain logarithmic expressions. All right, we'll be looking at one more concept in a minute when we need it, but we don't need it yet, so let's just Look at these guys. All right. Use the properties of logarithms to expand the following expression as much as possible. All right, so my properties of logarithms are the log of a product, the log of a quotient, and the log of something to a power. I don't have any of that. I don't have the log of a product. This isn't a product. I don't have log of a quotient. I don't have log of something to a power. So right now I'm going, how can I use these properties if I don't have a product, quotient, or something to a power? Well, I create one of these settings. I'm going to create a product. I'm going to factor this guy. So my first step here is factor using what we always look for first, the greatest common factor. So this right now can be expressed as something times something if I can factor it. So here we go. Log base 4. Greatest common factor of 20 and 8. Well, 2 will go into both of them. Hey, yeah, but 4 will go into both of them. So I'm going to take out a 4. And that'll be 5x plus 2y. So all I've done is factor using the greatest common factor. I took out a 4. Well, look what we got here. We've got the log of something times something. I have the log of something times something. Hey, that's this guy right here. Log of something times something. It's the log of the first thing plus the log of the second thing. So I'm simply going to change this to the log of the first thing plus the log of the second thing. Now I'm going to be needing to be on my toes, looking for logs of products, logs of quotients, or logs of something to a power. We created the product, so there's the log of the first plus the log of the second. Hey, this guy right here is looking awfully familiar and awfully suspicious. Log base 4, log base a of a, log base 4 is just going to be 1. Log base anything of itself is just going to be 1. That's one of our basic logarithmic concepts. So log base 4, that's just 1. It says expand as much as possible. I can do that. And that's as far as I can go. So that's the answer you're going to put into your Hawks. But don't forget to simplify log base 4 as 1. All right, that one's down. Use the properties of logarithms to condense. Now, in that first one, we used the property of logarithms to expand. We used our properties to go from left to right. Here we're going to use our properties to go from right to left. So for instance, we're going to look at the sum of a log and go, hey, that's the log of a product. We're going to look at the difference of a log and go, hey, that is the log of a quotient. We're going to look at a coefficient in front of a log and go, hey, wait a minute, that's the same as the log of something to that power. So we're going to go in the opposite direction here as we condense this expression. All right. The first thing we're going to notice is, notice they're all natural log, natural log, natural log, is I've got some coefficients. The first thing I'm going to deal with is the coefficients. And I know that a coefficient of a log, coefficient times a log, can be condensed to the log of something to a power. So the coefficient of this is 1. I'm going to leave it alone. So that's natural log of 12. Now this coefficient is going to become my exponent. Natural log of x to the 6th. This coefficient is going to become my exponent. Natural log of y squared. So we use the third property of logarithms, and we changed a coefficient into an exponent. All right, check out this. I've got the sum of two logs. Sum of two logs is the same as the log of a product. So I can condense the sum of two logs as the log of the product of these two things. Now, some of you are probably going to think of doing this all in one step. You can, but I'm doing it one step at a time. So I dealt with my coefficients right here and here. Change them to exponents. I saw a product. I changed that product of logs to the log of the sum of those two logs as the log of a product. Now I see the difference of two logs. And I know that the difference of two logs is the same as the log of the quotient of those two things. So the log of this minus the log of that equals the log of this over that. And that's my condensed expression. That's what I would put into my Hawks. All right. Next one. Those were kind of challenging. This one's thoroughly easy. Natural log of z plus natural log of 12x. Hey, that is the sum of two logs. That's simply the log of the product of those two values. So the sum of logs is the same as the log of these two things multiplied. So it's 12x times z. And that's it. The sum of two logs equals the log of their product. And I put the z second just to put it in alphabetical order because I'm a neat freak. All right, number 4. Use the properties of logarithms to, again, condense. That means you're going from right to left, the following expression. Check it out. Log of something minus log of something. Log of something minus log of something. That's the same as the log of the quotient. This over that. This is my numerator. This is my denominator. Y over 15. And that's it. Now, one thing I noticed on this particular problem was you and I both know that log without a base mentioned means log base 10. But on this particular problem, for whatever reason, Hawks required me to put in a visible base. So I had to write log base 10 of y over 15. So keep that in mind on this particular problem. All right. Moving right along. Evaluate. Round to 2 decimal places. Log base 1/9 of 0.67. Here's where I'm going to need my calculator. First of all, I find my log base 1/9 function key. I don't have one. All I have is a log base 10 and a log base e function key. That's all I got. Log base 10, log base e. So when they ask me for log base 1/9 of this value, yeah, I got nothing to do. That's when I need some additional information. Something called the change of base formula. See that base? That's an inconvenient base because I don't have a log to the 1/9 function key. So I need to change my base. So let me just step aside with this problem for a second, and let's look at this change of base formula. You guys may recall this. In our last week's problems, we looked at dealing with log base 2 of 8. Remember that? We substituted in the place of 8 what 8 is, 2 to the 3rd, and we got log base 2 of 2 to the 3rd. Well, this should look familiar. Log base 2 of 2 to the 3rd is just going to be 3. So if my two bases are identical, my logarithm is simply my exponent. So log base 2 of 2 to the 3rd is just going to be 3. So log base 2 of 2 to the 3rd just simplifies to 3. Yeah, but what if I had, and this was the question we asked, what if I had, instead of log base 2 of 8, what if I had log base 2 of 9? Now note, there is no 2 to any power that I can substitute for 9. 9 is 3 to the 3rd, so that doesn't help me at all. So I'm at an impasse. I need something to change my base so that I can evaluate what log base 2 of 9 is. And here is the change of base formula, and boy is this handy. Log base b of x equals log base a of x over log base a of b. Now notice, log base, I can change it. I can use any a that I choose, any base that I choose, just so long as it's consistent. So why wouldn't I use something that's very handy, that's very convenient, namely log base 10, I've got that on my calculator, or log base e, I've got that on my calculator. Let me read this. I am free to choose any positive number for my new base a. But since I have function keys on my calculator for log base 10 and for log base e, I might as well choose one of those. So when you change your base, the natural thing to do, the convenient thing to do, is to change it to a base 10 or to a base e. Why? Because I got those function keys on my calculator. So let's go back and look at log base 2 of 9. So let's evaluate log base 2 of 9 using this change of base formula. Log base 2 of 9 is log base 10 of the 9 over log base 10 of the 2. And notice, no base is mentioned. That means, of course, log base 10. Let me remind you once again of the formula. Log base b of x. I can pick my new base, and I picked 10. It's log base 10 of this first. It becomes my numerator. And log base 10 of this second. This goes in my denominator. So the 9 goes in my numerator, the 2 goes in my denominator, and hey, I have a calculator that will evaluate log base 10 of 9 and log base 10 of 2. So this just turns out to be a quotient. So I'm going to do log base 10 of 9, so I hit my log function key. Notice I have parentheses there, log of what? Log base 10 of 9. Now I'm going to hit equals so I can get my numerator. It's approximately, not approximately, it's 0.9542425, etc. Now I want to divide that by log of 2. So divide, notice my answer's on top, divide by log of 2. Log of 2 equals, and I get 3.169925. And they tell me to round this to 3 decimal places. I get 3.170. Well, what if I choose the natural log instead? What if I did the natural log of 9 over the natural log of 2. Let's do it. Again, this number goes in the numerator. This number goes in the denominator. So I'm going to use natural log instead. So I'm going to do natural log of 9. So I hit ln of 9 equals, and that gives me the natural log of 9, 2.19 something, divided by the natural log of 2. Natural log 2 equals. And I get, oh my goodness, exactly the same expression as I got when I did the common log. So it doesn't matter what base you choose, whether it's 10 or e, you're going to find that you're going to get the same quotient. One caution, on your calculator, be sure to hit the equals key before you do your division by the second log. That can save you from lots of grief. So I hit log base 10 of 9 equals before I divide it by the second log. Keep that in mind. So I now have a change of base formula. I have a change of base formula when my base is inconvenient, when I don't have a function key with which to evaluate it. So my problem was log base 1/9. I obviously don't have a 1/9 function key, so I'm going to be using my change of base formula. So here's problem 5. Evaluate this. Log base 1/9 of 0.67. I'm going to change that. I'm going to just go ahead and do the common log, the log base 10. So I'm going to change that to log of 0.67. That goes to my numerator, over log of 1/9. That goes to my denominator. Everybody get on that? So I'm going to do log of 0.67. Nothing I can do in my head. I got to use my calculator. Log of 0.67 equals, so I've got my numerator, divided by log of 1/9. I'm going to go 1 divide 9, close my parentheses. So I got log of 1/9 there, equals, and I get negative 0.954. That's the 3 decimal places. So let me do that one more time, just to make sure. Log, let me do natural log of 0.67 divided by natural log of 1/9. Just to double check, natural log of 0.67 equals, so I get a number, divided by natural log of 1 divide 9, close parentheses, equals. And I get something completely different. So I got here 0.182265. Hey, good learning experience. I got 2 different things for the logs. So let me try this one again, the log of 1/9. Possibly I hit a wrong logarithmic button. Let me try again. I'm going to do log of 0.67. Log 0.67 equals, and I get negative 0.177 divided by log of 1 divide 9, close parentheses, equals. Aha! Don't get that. I get 0.182265. Like I say, I like to demonstrate that even I am also fallible, occasionally make a mistake. So good thing to do. If you do log of 1, do the ln of the other and see if you get the same thing. So here is my solution. to 3 decimal places, 182. Oh, 2 decimal places, 0.18. So that's 2 decimal places. That's what I'm going to put into my Hawk's solution. All right, so if you have an inconvenient base, use your change of base formula. This goes here, this goes there. All right, last one. Use properties of logarithms to condense. That means I'm going to be going from right to left, from a sum to a product, from a difference to a quotient, from a coefficient to an exponent, something like that. Yeah, all right. All right, first thing we said, let's deal with our coefficients, 3, 2, and 6. These coefficients, if I'm condensing them, they become the exponents of whatever I'm taking the logarithm of. So this goes right there, this goes right there, this goes right there. So we get log to the 3rd power. The coefficient now becomes my exponent, plus log to the 2nd power. The coefficient becomes my exponent, minus log to the 6th. The coefficient becomes my exponent. All right, next, I see I've got a sum. Well, I'll tell you what I'm going to do first. I'm going to go ahead and kind of simplify this stuff right here. Powers to a power, right? Let's go ahead and simplify this. Powers to a power, I multiply the outer exponent by the inner exponents. X to the 6th, y to the 12th. Powers to a power. And this one doesn't change. Now, I've got the log, I've got the sum of 2 logs. Sum of 2 logs tells me I'm going to express this as the log of these 2 things multiplied, a product. But before I do that, I'm going to go ahead and change this to a more convenient expression so I can multiply straight across. I'm going to remind myself that I can move a term to the other part of the fraction if I change the sign of my exponent. So before I multiply these 2 values, I'm going to change log of 1 over x squared to log of x to the negative 2. Now you don't have to do that, but I'm going to do that just so I can combine my x's here. Now, I got the sum of 2 logs, so I'm going to multiply my 2 values. The sum of logs equals the log of a product. X to the 6th, y to the 12th, times x to the negative 2. Why did I do that? Why did I change this to negative 2? Because I can now simplify this. Look here. Have the same base. What do you do with your exponents when you have the same base? Add them together. 6 plus negative 2 is 4. All right, last step. I have the difference of 2 logs. I know from my properties of logarithms that the difference of 2 logs is the same as the log of their quotient, that over that. So it's going to be that over that. Difference of 2 logs is the log of a quotient, a fraction, that over that. Obviously, I have some simplification here to do. Same base, top and bottom in a fraction. I subtract the smaller exponent from the larger, wherever the larger happens to be. And there you have what you're going to submit to Hawks. All right, ladies and gentlemen, this is not an easy section, mainly because of all the new properties of logarithms and the change of base formula, but they're very doable. And you only got 6 problems on this particular section, so be sure and take care of that before Sunday at midnight. Hey, after this, we only got, goodness, 3 more sections. So stay focused. We will have another review, and for those of you that did look at the review that I had for the second test, which by numbers was about half of you looked at the review, the video review. That video review was of problems almost identical to the test problems. Same is going to be true for the video review for test number 3. If you see a problem on the review, there's going to be a problem like it on the test. If you don't see a problem on the review, that kind of problem will not be on the test. It's going to be a one-to-one correspondence between types of problems on the review and types of problems on the test. So take care of your Hawk sections, and we will review for test 3 when we get much closer to the date. Stay focused. And by the way, for those of you that are looking for something to read, I would highly suggest this book here. It's called The Birds Their Carols Raise. It's a book about growing up in East Texas during the 1960s. It's a fictional account. It's by, let's see, who's it by? Oh, it's by me. I forgot. Yeah, yes, it's actually by me. So you can find this book on Amazon.com if you're interested. And when life gets normal again, hey, I'll even sign it for you. You guys have a wonderful rest of this day. Take care of these sections, and I'll see you next time.